So today we will discussing about how LCDs are used, in embedded systems. So LCDs are very commonly available in two types. So LCDs are available as a two-line LCD 2x16, 2x20. Am I audible?
Yes, sir.
Yeah. So basically the LCDs, what is used in embedded systems are called as character LCDs. So character LCDs are the LCDs, so where you can display the characters on the LCDs. So now, whenever you want to display something on the LCDs, what is required? So you should be able to send what is a character to be displayed from the programmer, that is the programmer or the microcontroller should send to the LCD. What is the format of sending the data to the LCD is always ASCII code. ASCII code is the format or the communication media or the communication standard used, is a protocol used to send the data to the LCDs. So the microcontroller or the programmer pushes the data ASCII codes into this one. So whenever you want to display, for example, the character A, if you look at every one character in LCD, you just bring that one character, blow it up and see that every character is formed by a set of dots or called a set of pixels. For example, 5x7 dots or 5x10 dots like that. So these dots should be made on to get, for example, if I want to display A, that means that corresponding dot should be on to get this character. But what is the programmer is giving to the LCD? He is giving an ASCII code. For example, 30 is an ASCII code for 0. So from the 30, you cannot get the information about which bits to be on. So what is required? You require some information about which are the bits to be on. Then for that, what is required? So you should require what is called these patterns to be stored somewhere. So where is you have to store the patterns? That means that you have to provide some memory inside an LCD. That memory will contains the patterns to be displayed on this one. So that memory LCD which contains the patterns to be displayed is called as character generator RAM. So what is the programmer source? That is stored in a dynamic display RAM. So this RAM, DDRAM, so contains all the ASCII codes to be displayed on the two lines. For every ASCII code, what is the bit patterns to be produced? That is stored in a character generator RAM. Since we know that we have already learned in 7-segment display, it is always easier and efficient when we convert the byte into the bits and push the data to make the segments or to make the LEDs or the bits to glow. For that, shift registers have been provided inside an LCD, which will convert this byte data stored in a character generator RAM into the bit data and make the pixels on and off. So the pixel drivers and the refreshing circuit are provided so that the display looks stationary whenever you push certain data and ask to hold the data on the LCD. So to control all these peripherals, the DDRAM, CGRAM, the shift register, everything, one controller is required inside an LCD. So a small controller, microcontroller is present inside an LCD. That's why we call LCD itself is a small size embedded system, because which has got inside a controller memory, read-only memory, and all other hardware interfacing logics are required. So summarizing, LCD is a small size embedded system with a controller. Now, once I know that what is present inside an LCD, now the question is, what are the lines are provided by these LCDs for interfacing with the microcontrollers? Now let's look at these lines. Now look at these lines, what are required. Now this is an LCD module. All the LCDs, whether you purchase the 2x16 or 4x20, the number of pins what is provided for interfacing is 1 to 16. So 1 to 16 is the number of pins provided for all the LCD modules. Now we'll group these pins into three things. These LCD pins are grouped into three things. So before we understand these pins, let us understand now how does LCD works interfacing. That is the protocol between the LCD and the microcontroller works. Let us assume that I have a microcontroller. Let's say LPC2148. It can be used for any microcontroller. Now this microcontroller has to communicate with the LCD. So when I want to communicate with the LCD, so what are the requirements a microcontroller should satisfy whenever an LCD is interfaced to the microcontroller? Number one, there is a lot of programming that is setting you to do before start using an LCD. What are the settings you're supposed to do it? For example, if you have a 2 lines LCD is there, do you require a 1 line LCD, or you require both the lines is required LCD? That is, you can configure it. If there are 4 lines are there, how many lines I'll be using, that I can configure it. Number 2. Now, this number of bit patterns, what you have, you can see here, this I can configure to work as what, 5 cross 7 or 5 cross, I can configure them as what, 5 cross 7 or 5 cross 10. So there are 2 configurations I can able to do it, 5 cross 7 dots or 5 cross 10 dots, that I can configure it. Now, so whenever I am not interested to display something, there is a possibility is there to switch off this display. That means LCD is on, but I can switch off the display that. Whenever required, I can switch on the display. And whenever you display the character, there is what is called small cursor will come on the LCD. You can make the cursor also appear on the LCD. Or you want a blinking cursor, I can make the cursor blink also. And there's one more facility is there in LCD. Even though I said there are 16 characters are there in a 2-line LCD, it is possible to push 40 characters for 1 line. How it is possible? Because inside the microcontroller, there is a memory is there where you store the ASCII code. Even though 16 you can display at a time, but how much they dedicate? They dedicate 40 bytes for the first line. You can display 16 only, but inside you can store 40 bytes. Then you can ask the question, sir, what is the use of 40 bytes? I can display only 16. There is a facility called as shifting the characters. You can able to produce what is called rotating effect. So that means that you can produce the rotation. This rotation we could have done in 7-segment also. We have not done that. You can try the program in a 7-segment also. In 7-segment also you can rotate a display. You have seen in the buses now you can rotate the display. So similarly here also. So it is possible to rotate the display here. There is a command are there. Microcontroller, if you issue the shift command, the 40 characters can be displayed 16 at a time. So because of that, they provide what is called as 40 characters for every line of display. So totally how much of memory is there? 80 bytes is there inside the LCD. So 140 bytes is meant for 1 line of information to be displayed here. Now, so these things I program or configure before I start using the thing. What are the things? For example, the size of the pixel, the size of the characters, then the bit patterns, 5 cross 7 and 5 cross 10 I can do it. Number of lines, 1 or 2 I can do it. I can shift the data or I can make it stationary. I can switch off the display, I can switch on the display. Like so many informations I can able to instruct the LCD. So whatever the information you are sending to the LCD will be of 2 types. The first one is called, you can send them what is called as commands. So these types of configuring the LCD, we use a word called as commands. So what is the meaning of commands? Commands are nothing but instruction to LCD, how you have to behave at the time of running the project or running the program. So the commands are shift command, clear the command, make the 2 lines, make the 1 line. These are all called commands. Once the LCD is configured, that means that first job is done by the microcontroller. What is the second job? What is the data to be displayed on the LCD? You have to push the data into the LCD. So that means that ASCII codes of the character to be displayed, you have to send it. So that whatever you send it, which is to be displayed on the LCD, we call them as not the commands, we call them as data. So indirectly, now I can say that there are 2 informations I can put into the LCD. One is called as commands, other is called as a data. So LCD should able to understand each time it receives the data, is it a command or is it a data? If it's a command, treat them differently. If it's a data, take the data and put it into the RAM. Like that, LCD should able to understand now. Now, having understood this concept, now let's come back to the pins there. These 16 pins, whatever available here, these 16 pins are used to establish an handshaking or establishing an interfacing between the microcontrollers. Now, these 16 pins, I will group into 3 parts. The power supply related pins, the handshaking pins, that is which is used to establish an interfacing or an understanding between the microcontroller, I'll call as a handshaking pins, then I'll call as a data pins. So I have grouped them into 3 types. So power supply, handshaking, and the data. Now we will understand one by one. Now look at that. LCD itself is a small size embedded system. You require a power that to work. What is the power LCDs require? LCDs work at 5 voltage. So that means that ground is the first pin, VCC is the second pin. This is the power supply pins. You have to provide 5 volts and the ground for this one. So one part of the power supply done. There are other power related pins there. We will understand that one. Now there is what is called VO. See, you can see that there is a third pin, always the third pin. Third pin is called as contrast. What is the meaning of a contrast? You look at the intensity of the blockness of these dots. Look at the intensity here. There is no intensity here. Even though there are dots are there, it's not visible here. The dots are visible here. That means that this intensity of the dots I can control by using what is called as VO pin, by applying the variable voltage here. How do you apply the variable voltage? A potentiometer can be used. The potentiometer, both the ends can be connected to one to the VCC, one to the ground, so that you can make the pot vary. By varying the pot, I can apply at this point 0 to, I can apply at this point what? 0 to 5 volts. Many times when you do the project, when you first time you build the project, LCDs are working, program is working, but you are not getting any characters on the LCD. Because why? The contrast has not been adjusted properly, even in the laboratory also. What you have to do, just look at the LCD. Near to the LCD, one potentiometer will be there. This will be there near to the LCD. Just look at that, take the screwdriver and adjust this part. When you adjust this part, immediately the characters start displaying it. One of the reasons why you don't get it is this, you are not adjusted this properly. This is called as contrast adjustment. Contrast means adjusting the brightness of the dots. So that is called as a contrast adjustment. Now, other one aspect is there for the related to the power. So one is called as these two. So this is called backlight. So what is the meaning of a backlight? That means that whenever, for example, you look at that backlight is already glowing here. When you see that, sometimes some LCDs do not have any light. You go to the near to the embedded system, press a key, immediately light appears on the LCD. That means that there is a light is there, background. A small LED light has been put on the background of an LCD. You can switch on the light, you can switch off the light. If it's a power, if your embedded system is running from the battery, generally we switch off the light. Only when it is required, we switch on the LED. In most of the projects, we don't do this option. We permanently make the backlight on. So these are the two pins, 15 and 16, the backlight pins. So there are two pins at 15, 16. Connect a 5 volt supply here. If you connect a 5 volt supply here, then what will happen? So one to the ground, other to the 5 volts. If you connect it, immediately the backlight is on. So these are the 6 pins which are related to the power supply. What are the pins? VCC and ground, which gives the power to the microcontroller and the logics inside. The VB1 and VB0, this gives a backlight enablement for the LCD, and the VO, the third pin, is given for the contrast adjustment. So totally there are 5 pins are there. These 5 pins are dedicated for the power related aspect of the LCD. Now we have finished the first set of the pins. So we will go to the second set of the pins. So we will go to the second set of the pins now. Okay. So second set of the pins, as I said, is called as handshaking pins. So you clearly understand here the two things, requirements here. Whether LCD is output device or LCD is an input device or LCD is an input output device. If I ask you the question, generally what do you see? Because you are displaying something on the LCD, you are pushing the data from the microcontroller here. You may say that, oh, LCD is an output device, sir. But no, LCD can able to supply the data to the microcontroller also. You may ask the question, sir, what is the necessity of microcontroller receiving the data from an LCD? This is for the simple reason. The microcontroller, what is used in LCD, is a low-speed microcontroller, very low-speed microcontroller. The microcontrollers, what you use these days, they work at 60 megahertz, 100 megahertz like that. That means that microcontrollers work at a higher speeds. LCDs will work at a lower speeds. If I want to push some data to be displayed on the LCD, if I push one character, yes or no, the LCD should be able to read that character, digest that character, and display on the LCD. Then only it can be ready to receive the next character. But since the microcontroller works at 100 megahertz, this will work at 10 megahertz. If you're able to push all the data at 100 megahertz, LCD will lose all the data. LCD is not in a position to receive the data. That is why the microcontroller should be able to supply the data to the LCD at the speed what is consumable, at the speed what is required by the LCD, what it can understand. So that means that the rate at which a microcontroller works, the rate at which the LCD works is different. So there should be an understanding should be there. So for that, we require what is called as status. Status means I'll push one character, let's say A character to be displayed here. Then what will happen? I will read the LCD inside. So reading the LCD means what? There is a register inside called as a status register, SR, status register. I will read that. So this register, when I read from the microcontroller, so there is a bit is available here, whether it is busy or not busy. If it is not busy, then only I'll push the next character. That means that microcontrollers send one character, then checks the status register. whether the previously sent character is being completely digested, has been used, and has been done the job, then only I can push the next character. Otherwise, I'll not put it. So that is why. So sometimes we can use a microcontroller for reading purpose also. But many times in the project, to make it simple, so including the program what we're developing, we neglect this option called as status register. Because why? I know that LCD works slowly. After pushing every one character, I will give a delay. Approximately, I'll give certain sufficient delay so that LCD is able to take the character and display in that one. Either you can go method of going to a method called status checking or called as a handshaking. Using this method, you can go for it. Or you can introduce a delay between the characters. Both methods we can go it. So if you are going for the delay method, then you are not writing, you are not reading the LCD. You are always only writing the LCD. So that is why one pin is provided for handshaking. That pin is called read write. Yes or no? So this read write, the microcontroller should able to make this pin. This pin is equal to what? Either 1 or 0, depends upon whether you are reading or writing. If I'm permanently writing only, I'm not reading, I'm following a delay method in my implementing my algorithms, I can ground this pin. I can permanently ground this pin. So this you should be able to understand that. So that is read write pin. So either we can implement in the algorithm or in the interfacing, or we can able to permanently make it write. So this you have to understand. See that the meaning, if 0 means write to LCD, so 1 means read from the LCD. There is a status register. So this you can use it or you need not use it. If you are not using, you can ground this pin, or RW is grounded. In this problem, whatever we are doing now, I have grounded the read write pin now. So now I have understood that LCD is both a read write device now. Now to establish communication between the microcontroller and LCD, now what is the I require? I said microcontroller pushes 2 types of data into LCD. One is it pushes the commands or it pushes the data. Whenever you push the data to the microcontroller, from the microcontroller to the LCD, there is only one data bus is there, through that you can push the data. What is the data bus? Look at here. That is a third set of bus, D0 to D7. So what is that size of the data bus? 8-bit bus. So LCD is what? It's an 8-bit bus microcontroller. LCD inside has got a microcontroller, so which communicates using what? 8-bit bus. So communication between the LCD and the other external microcontroller is what? 8-bit bus. So that command, 1 byte is 1 command, or you can write 1 byte what? ASCII code you can able to write it. So whenever you write the data into the LCD, how does the LCD knows that whether you have written a data or you have written a command? LCD does not know that. So it is a responsibility of the programmer, that is a microcontroller, to inform to the LCD, I have written a data, I have written the command. For that, they provided one handshaking signal called RS. So RS is the 4th pin. RS is called register select. So look at the RS. What is the meaning of the RS? Whenever RS is 0, that means that whatever the data I supply in the data bus is called as what? Command. It goes into the command register for LCD. Whenever RS is equal to 1, you supply the data. LCD think that it's an ASCII code, and the data goes to what? The data register on LCD and then goes to the DDRAM. So that means that RS is an important signal. Now whenever we interface, so from the microcontroller should able to set this bit properly through the programming, either 1 or 0, based on whether you are writing the data or you are writing the command. Now, so the last handshaking signals now. Now, let's say you have written this data here. I am not using the write bar method. I said write bar is not available. I am using, write bar, WR bar, I grounded it. That means that I am writing always. Now, let's say I am going to write certain data on this one. Let's say I want to write character A. So what I'll do is I will send the character A to the LCD. So I will send A. So where does the A comes? A comes on these bit patterns. That means that A sits here. So what is an ASCII code of A? Whatever the 65 or whatever the ASCII code is available for that, that will be put on these lines by the microcontrollers on this one. Now, after displaying the A, I want to display another A. So I've given certain delay in the microcontroller. Now again, I'll send another character A. Now, so again A comes here. A data ASCII code of the A will come and sit here on the data bus. Who sends it? Microcontroller sends it. Again, after some time, I'll send another A. So again, you're sending an ASCII code here. Now tell me, how does an LCD knows that whether the new character is placed or it's an old A? See, you placed A here. That means that I'm placing first A here. Yes or no? Now I give certain delay. So how does the microcontroller knows that how much time you place the A, and is it a old A or the new A? After some time I place another A, but the ASCII code is not changed. The code is similar. Since I am displaying the same characters many number of times, the code is not changed. How does the microcontroller know that? Is it a first A, or is it a second A, or is it the third A? That means that whenever you put certain data on the microcontroller, it is the responsibility of the microcontroller to generate a handshaking signal to the LCD saying that I have placed the data, please copy it inside. That means that one pulse is to be generated. That pulse, like a clock pulse, which gives an information to the LCD, please copy the data inside. One data is finished. So that means that for that, there is a signal called as E0, enable signal. So this will be like this pulse. So it's a high to low pulse. That means that each time you put the data, so you have to generate what is called high to low pulse. Whenever high to low pulse is generated, the microcontroller knows that, oh, you place the data. So immediately whenever the pulse generates, the LCD microcontroller copies this data into the proper place, either into the command register or into the data register. So if you don't generate this pulse, LCD does not know that you place the data, whether the previous data or the new data, it does not know that. So this is the handshaking signal, which is very essential from the microcontroller to generate. Summarizing now, so the power supply, 5 pins are there. Data, ASCII code or the command, 8 lines are there. 2 handshaking signals are there called as RS and so RS, read WO, enable. These are the 3 handshaking signals which is present in a microcontroller. These signal handshaking signals. Now in this one, read write bar, we always permanently ground it. Then you left it only RS and the enable. What is the purpose of an RS? RS informs to the LCD that the microcontroller is sending a command or data. Enable informs to the microcontroller, I have placed a new data, please copy it inside. So that is the meaning of this one. How does enable comes? Enable has to be what? You have to generate first one high for 450 nanoseconds. You have to make it high. That means that you have to keep it high for 450 nanoseconds. Then you have to make it 0. That means that, so this logic you have to produce. So how much time? So 450 nanoseconds you have to make it. So this is a standard for most of the commercial LCDs available in the market. So this is how the technical information you're supposed to know that whenever you want to connect this LCD to any of the microcontrollers and develop a library. Am I audible?
Yes, sir.
Now, now we will interface. Since we have understood all the 16 pins of the LCD now I will interface this to the LPC2148. Now, I have chosen P0, 16, 17, 18, 19. I have connected to D4, D5, D6, D7. Now you may be wondering, sir said there are 8 pins are available to send an ASCII code. You're using only 4 pins are there. This is the advantage of an LCD. This is a beautiful concept or beautiful facility provided in the LCD manufacturers. LCD manufacturers knows that the number of pins of a microcontroller is very valuable, very important. Microcontrollers do not have much of the IO pins there because microcontroller pins are used for so many things. So they have provided 2 modes of operation within LCDs. One is called as a byte mode, other is called as a nibble mode. That means that microcontrollers can communicate to the LCD using 2 modes. One is called as the byte mode. So in case of a byte mode, the data or the command what you're sending to the microcontroller to the LCD is all the 8 pins of the microcontroller used, all the 8 pins of the LCD is used. All 1 byte at a time you push the data to the microcontroller and receives it. In case of a nibble mode, so since if the pins are not available in a microcontroller, because pins are very less pins are available in the microcontroller, you have to use the pins for so many other projects, so many other things in a project, then you can always use what is called nibble mode. In a nibble mode, I am sending 1 byte, breaking into 2 nibbles and push it. First, always the upper nibble I'll push it, then the lower nibble I'll push it. So it is the programmer and the interfacing engineer decision whether I should go for a nibble mode of interfacing or a byte mode of interfacing. In this project, so what I'm going to explain now, the program what I've developed, I've used a nibble mode. Almost the whole of the program remains same thing, except one function where you can change from nibble to byte mode also. So in the interfacing, what is the change? If you use all the other pins, that is D3, D2, D1, D0, so and provide another 4 pins for the microcontroller. Then interfacing is what? Byte mode of interfacing. That's all. That is the only difference. All other things remain same thing. Only thing is 4 bits or 8 bits of a microcontroller you want to use to send the data. That is the only thing you have to take a decision. Now look at the interfacing. Interfacing is complete. So the backlight and the VCC I connect to the 5 volts. I made the backlight on. I provided a potentiometer to adjust the contrast of the pixels or the bits. So the VSS read write permanently grounded so that I'm only writing the into the LCD. So I've used P0.20, P1.25 for the RS and the enable pins of the LCD to generate. The basic function now what is we require is what? How do I push my 8-bit of data on the 4-bit lines? That is my first requirement. So I have written one function. So what is that function? One function. In that function, if you give 8-bit of data, it takes the 4 bits, it takes the upper 4 bits and copy onto the D4, D5, D6, D7 line. First I have written that one. So what that I given? Because you are going to send either command bytes or the data bytes. It is, since you are using a nibble mode, I can write only one nibble at a time. I require a function to take the upper 4 bits of the byte you are supplying to the function and copy to the D4, D5, D6, 7. I require it. Yes or no? So now what I will do is, so I will develop one such function, so which copies the upper 4 bits of a byte and copies to here. So how I have done? So just imagine that 16, 17, 18, 19 is the bits I supposed to do it here. Now I have to push only what? Upper bits. Let's say that. So let's say that the byte, whatever I'm going to push, I just only show that. Don't look at any other things. Okay. Now, so let your focus only on this one. Let your focus only on this one. Don't see anything else. Your focus only on this one now. So what is this send higher nibble I have written is, since I'm working in the nibble mode, whatever the byte I'm going to get as a part of this function, that is a one character, one byte, I want to take the upper 4 bits of this byte and put in the 16 to 17, 18, 19. What is the logic I required it? Now, so what I will do is, first I will clear all the 4 bits 16, 17, 18, 19 by writing F in that position. So I am writing this pattern into what? IO clear register. When I write this pattern into the IO clear register, what will happen? Since you're writing into clear register, 16, 17, 18, 19 become clear. Then whatever the byte is supposed to write it, I'm going to write only the upper 4 bits. Then what I will do is, this, since it's an 8-bit, the data byte is an 8 bits. Since I am interested only upper nibble, I will shift it, right shift it by 4 times. Then what I'll get it? Upper nibble becomes a lower nibble. So for example, if I have 76 is the number, which is let's say an example I have taken here. Whenever you take data byte right shift by 4, so what do you get? 76 becomes what? The 7 will come to this right side. That means that it becomes what? 07. It becomes 07. So that I brought the upper nibble into what? Lower nibble position. Then, since I'm not sure that it is, most of the compilers are automatically, when you shift it, the empty portions will become 0, but I have explicitly done one more time. I want to clear this into 0. That is why I'm ANDing with a 0F. 0F means what? Only the upper nibble will become clear. The lower nibble, whatever the value, it will remain as it is. Even if you avoid this also, it works. But I've just given explicitly, irrespective of whichever the compiler you use it. So now, whenever I do this one, what will happen? So I am getting the upper nibble of this 8-bit number. I got it now. Now, once I got this upper nibble, that is a 4-bit, I want to place this data on the 16, 17, 18, 19. Because it's 16, it's starting from 16, I'm shifting this upper nibble 16 times. So whenever I shift it to the 16 times, what will happen? This nibble, upper nibble, will come exactly at this position. Since already the bits have been made 0, I am writing this one. Whatever the upper nibble will exactly sit on the P0.16 to 19. This is what embedded C is all. See, in a normal C, you don't do this type of manipulation. Only in case of driver development, only when you do the low-level programming, you do these manipulations, ANDing, shifting, making the pins receive the required. This is called as the embedded C, the typical characteristics of embedded C. So now what I have done, so I got the upper nibble, then I shifted 16 bits so that I got that nibble placed exactly in the pins 16, 17, 18, 19. So now, so this is done. So I have got a function called send higher nibble. So now we'll go back to here. So let's go back to here. So now what I've done, I have written one function. What is the name of the function? Send a higher nibble. So whenever I give a byte, so any byte will send a higher nibble, the upper nibble will come and exactly return into this portion. I did it. Now I will write, now I got the basic functions available. Now I have to develop two functions. Now I have to develop two functions to make the LCD receives the data. Now I said the type of data what you push to the LCD is of two types. Either you push the command or you push the data. If I'm pushing the command, you have to make RS is equal to what? This line is equal to what? You have to make 0. So if I'm pushing the data, I have to make RS is equal to what? 1. Now we will write two functions now. So writing the command write and the data write. So I will develop now two functions. One function is for what? Writing the commands. Other function is what? Writing the ASCII codes. So each of the functions, if I call it, I will pass to that function what? Either command I'll pass or I'll pass what? I'll pass the data I'm going to pass it. So two functions I develop it. In each of the functions, what is the basic thing you have to take care? That means that first you have to make the RS is equal to 0 or 1, depends upon the command and data. Then you have to place the data. Then you have to place the data. Then you have to generate an enable pulse so that what will happen? The data is written into this one. So three things I have to do in these two functions. What are the three things? Number one, set the RS, indicating whether you are writing command or a data. Second is what? Place the data on the D4, D5, D6, 7. How do you place the data? We know that send higher nibble function, I already written it. So, but how many times you have to call that function? 2 times you have to call. So first I will place the higher nibble of the byte. Then I'll take the lower nibble and again call the same function and place it. That means that if I want to write 76, I'll call the higher nibble and place first 7. Then again I'll call the send higher nibble, take the 6, shift it to the left, and again call the function one more time and send it here. So I'm able to place this one. So these three steps: setting RS, placing the data here, nibble at a time, one nibble at a time, then generating an enable. Three things I'm going to do in the two functions called as command write function and a data write function. Now we'll go to that functions. So now I'm going to write two functions called as command write and a data write. Okay. So now look at here. Now only look at those functions which I'm explaining. So now the second function I'm explaining. What is the second function? Command write. So this command write, the name of the function is called send command signal. So send data signal. So what I'm doing here, so I just I will call here. Send command write. Okay, so this is a function I'm calling inside the functions. So what is this function I'm telling about now? Send command. So command write is a function. What is I'm passing? The command, 8-bit command, which is supposed to write to the LCD. I have to pass this one. So whenever I call LCD command write, some command I give it, immediately what will happen? This code will be able to send this command push into the LCD. So what are the steps required? First step. So I said you have to make what is called as higher nibble. I have to send a command, but first I have to send an higher nibble, then send command signal, then again command byte lower nibble, send higher nibble, and then send the command signal. We'll understand in a little by little here. Now let us take an example. Let's say 86 is a command. So now what is I'm going to do now? I will take 8 now. So how do I take 8 now? LCD send higher nibble command byte. So if I write 86 as it is here, we know that in the send higher nibble I am taking only upper nibble and I am writing it. So this I send it. Now as soon as I send an upper nibble, yes or no, you have to make two things. What are the two things you have to make? You have to make RS proper value and also enable lines you have to do it. Instead of writing RS and enable always here, I written a small function called send command signals. So let's go to the send command signal only. Now understand the send command. What is the send command signal? I am making RS is equal to off or 0. I've hash defined RS into two things, RS on and RS off in the beginning of a program. So you can look at the program here. I just made there's a P0.20 is the RS signal. So this is RS on means what? Making the P0.20 on. RS off means what? P0.20 is equal to 0. That means that I've just defined that one. So what I have written here, so in the send command signal, I'll make the RS off. Because why? Whenever you want to write the command, you have to make the RS is equal to off. That is why I'm just calling this one. Then I said you have to generate a pulse called high to low. That is enable on. Similarly, enable on and enable off are defined. So earlier defined for a particular pin. You can look at that. So enable on. So enable off. This is P1.25 on and off has been defined as enable on and off. So I've just written here. So what I've written, enable on, enable off. So whenever I send command signal, if I call this one, what will happen? The handshaking is produced and whatever the data is there in the database will go inside the LCD. That you have to understand that. Now I'll come back to here. Now what I've written the upper nibble and the data lines, then the command signal. Whenever I call the send command signal, what I say, it produces a handshaking lines on the RS and enable. So the data, whatever you placed, copied inside an LCD. Now I have sent only one nibble. I have to send another nibble. What is another nibble? 6. So get the 6 into this position, that is upper position. Then what I done? So command byte left shift by 4. When I say left shift by 4, what will happen? 6 will come to this 8th position because I am copying higher nibble. When I say send higher nibble, it copies only the last 4 bits into the LCD D4 to D7. That is why I'm just shifting here. So again, do this operation, get the lower nibble into higher nibble, again send higher nibble. So then higher nibble will be copied and the data bits of the LCD, then send again command signals. So these are the steps required to send one command byte into an LCD. So what are the things required? First, send an upper nibble, generate a handshaking signals. Get the lower nibble into the upper nibble position, again send the handshaking signals. So by doing this one, I'm able to push the command into the LCD. Now let's understand how do we write the data write. So it's command write is same as data write, except that only thing is the send command signals is a change the function. So now this is the data write. So when do I use this one? Whenever I want to display ASCII code, I want to push an ASCII code, not the command, I will call this function. How do you call this function? First, get the higher nibble. Instead of send command signal, I written send data signal function. What is the difference between a send data signal and command signal? Only one difference is there. RS is high. So let's see that. So see that what is the difference between this function and the previous function? Here RS is off, here is RS is on. Otherwise it's same thing. Both the functions are same thing. So here RS off, here RS is on. So now I am able to push the data into the LCD. So now again the same thing. Get the lower nibble, push the other nibble, and generate a handshake signal. So LCD data write and LCD command write, both are same thing. You can just copy and paste it. Only difference is what? Here you make RS is equal to 1. Here you make RS is equal to 0. That is the only difference. Now I have finished both the functions now. Now I can write the command into LCD. I can write data into an LCD. Now we will start using the LCD now. How do you start using an LCD? Whenever you start using an LCD, first of all, you have to initialize an LCD. So you have to initialize an LCD. What is the meaning of initializing an LCD? I said you have to set up the LCD before start using it. So what are the initializations we have to do it? So these are the initializations which will be done in an LCD usually. So this is a standard pattern. This is a standard parameter. So only thing, these values, whatever I've chosen, defines the mode of your LCD working. For example, I want 5x7 bit pattern. So that for that 28 is the command you have to write it. So how do we prepare these commands? There's a table is given already. Using the table, I can prepare the commands. For example, these are the command tables. So you can choose whatever the option required. For example, so I said I require a function set. That means I require 5x7 dots. Yes or no? So this bit, F bit, I have to make it what? 0. So data lines, the number of lines you require a 4-bit interface or nibble or 8-bit byte interface. So I require a nibble interface. So I'll write this is equal to DL is equal to 0. Number of lines required. You want a 2-line LCD or a 1-line LCD? I wanted 2 lines. So I'll make this n is equal to what? 1. So these things I don't want. So I'll make it 0. So what do I got it? 0, 0, 0, 1, 0, 1, 0. This is equivalent to what? 28. I got it. So this is like this, based on the options you require, you have to prepare the commands. Once the commands are available for you, you can just set that commands in this function. So what is command? LCD initialization. 28 is the option I have set because I require those options. Next, after this, I have to display the on. I have to switch on the display, clear the complete memory and make it empty LCD and make the cursor on. So for that, what is a command? 0E is a command. Then I have to clear the LCD. So 01, that is clear the memory. So here only the display is on, cursor is on, the memory contents is not cleared. 01 is a command to clear the LCD. Then I want to, which line you want to go for that? You have to give a commands, different commands for the different lines. For example, if I send 80, the cursor is ghost, cursor is set for the first line. If I give a C0, cursor is goes to the second line beginning. If I give 94, X94, cursor is goes to the third line. Like that, there are commands there. Through that, you can able to define where is your cursor should be set. So LCD init is done. So now I have done the LCD initialization. So this is a delay MS. I will call some delay, then I'll call this one. Usually before start using an LCD in the beginning, then what we do is, so we will run this initial command before start using LCD. This is standard. Almost for most of the project, these are the standard. 28, 0E, 01, 08 is a standard. We will call this one. So now I call this one. Now my program is ready. Now the complete, I'll come to the main program. So I've defined all the functions. So I know that command write function I implemented, data write function. These two in turn uses what? So these two in turn uses what? Send data signal, send command signal. In turn, these two functions uses what? Send higher nibble. So these are the 5 functions now we have understood now. How do you write a data? How do you write a command? Yes or no? So using these two sub functions. Now also I have written what is called as LCD init also to make it LCD ready for working. Now I'll write my application program. What is an application program? So I've just used an interface which is used by the application engineer. These things will be written by what? As a part of a library, an engineer who supplies LCD supplies this library, or somebody would have written it. Now, as an application programmer, use what? Display string. So what is a display string? I will pass the string. So now I will implement a display string function. Look at the display string function now. So how does a display string function will work? Now, display string function, what does it take? It takes every character to be displayed here, while if the character is not 0, then I'll call what is called LCD data write. That's all I'm going to do it. So this is my display string function. So whatever you're passing as an array, take one by one character, push into the LCD using a data write function. Now it finishes. So now once I'm able to use this function, it's available, this function is available, I can implement an LCD based applications in my projects. So look at the main program now. So our main program I have written only to display 4 strings on 4 lines of the LCD. So first I will init, I'll do the initialization. So then I'll call the command. This command is set the cursor to the first line. Then I'll call the display string, display the RV colors of engineer, set the cursor to the second line, set the cursor to the third line, set the cursor to the 4th line, and then display it. So this is how we can interface an LCD to the microcontroller, and it can develop a library and start using the library function to as a part of the projects in any of the LCD based projects. So this completes today's discussion about the LCD. So you can just type in this code and just go through this code. So hopefully if there's any facility for the lab, you can able to work in the lab. So this cannot be done in the simulator. Actually, you should be able to connect the LCD to the kit and then able to try. So just understand that how we have developed a LCD, how we have done an interfacing to the LCD, how commands are there for a LCD. So if any doubt is there, you can just raise your doubt. So this completes. So today's discussion about LCD, how LCDs are available in the market, how LCDs can be used for any of the microcontroller projects, how you can develop a library for a LCD. Any doubts, you can raise it.
So I had a doubt. So what, can you give an example of what command we might use? Like data is okay, you might give like a string, but
for example,
command?
Yeah. So commands, whatever I said, no, 28, 0E, 01, yes or no? These are the commands which has to be sent to the LCD in the beginning of a program, only one time, beginning of the project. So that is what I've used in the init command here. So when I say LCD init, these nothing but sending certain 4 commands inside this one. What are the commands? Setting the functionality of the LCD, making the LCD on, clearing the LCD display. All those things are there in the init command. So what are the command in LCD? I said no, 280E. So these are the standard commands. This is the command we use. And other than that, we use what commands means setting the cursor, setting the cursor we use it. For example, here. So if I don't set the cursor, it's always start from the first character and it start flowing in the memory. Yes or no? So you should make sure that these commands to be given before the string is to be displayed. So this is another example for commands.
Okay.
Okay, so today I'm not taking the attendance. Whatever the previous attendance, I just carried. So probably 12:30 is there. I think you can go for the next class. So we will have one special class. I'll let you know when is a special class. 1 hour because of Monday I missed. That is, I will just let you know the timings in the WhatsApp group. So please practice the keyboard program because in the lab, with the Friday lab, whoever has got the Friday lab, you have to do the keyboard program. And one more question. So we will be giving on the spot tomorrow in the lab. So that make sure that all the programs understand and do it.
Edition. But I figured out if you've ever